Hello, my dear students of third prep. Today we are going to have a new geometry lesson whose title is The Coordinates of the Midpoint of a Line Segment. Let us start by the first example. If point A is 1 and 3, point B is 5 and 3, and I want to plot them graphically. So try to draw the x-axis and the y-axis and try to plot the point A as 1 and 3, point B as 5 and 3. First of all, join A and B. It is a line segment. What about the midpoint of this line segment? If the point C is the midpoint as it is put in the middle of AB. So C is the midpoint. Then, what about the coordinates of the point C? You are going to notice that the point C will be 3 and 3. This means that AB is represented by a line segment parallel to the x-axis. Then, the midpoint of AB is the point C, whose coordinates are 3 and 3. What do you notice? Here you notice that to find the x coordinate, you are going to add 1 plus 5, and then the result will be divided by 2 as it is the middle to obtain a result as 3. What about the y coordinate of the point C? Yes, you are going to notice that it is 3 plus 3 divided by 2 to obtain a result as 3. So, we can say that to find the coordinates of the point C, you are going to add x plus x over 2 and the y plus ly over 2 to obtain the coordinates of the midpoint of AB. What about another 2 points, A, -2 and -6, and B, -2 and -2? These 2 points, we want to plot them graphically. So we are going to draw the 2 axes, the x-axis and the y-axis, plot the first point A, which is -2 and -6, B, -2 and -2, join AB as it is a line segment. Then you are going to notice that the point C will be the midpoint of AB. And here we can say that the point C will be -2 and -4 from the graph. So, AB is represented by a straight line parallel to the y-axis, and the midpoint of AB is the point C. What about the coordinates of the point C? Yes, you are going to notice that the coordinates of the point C will be -2 and -4. How can you find it? Yes, by adding -2 plus -2 over 2 to obtain a result as -2. What about the y coordinate of the point C? It is -6 plus -2 over 2 to obtain a result as -4. Try to concentrate and look carefully at the figure drawn in front of you. Then, here this AB is parallel to the y-axis. If AB is neither parallel to the y-axis nor to the x-axis, what are you going to notice? Look carefully at the following figure. If A is 1 and 2, B is 5 and 6, try to plot it graphically. So A equals 1 and 2, B equals 5 and 6. Try to join AB and find the midpoint, which is C. Then C is the midpoint of AB. You notice that its coordinates are 3 and 4. How? If C is the midpoint of AB, then C equals 1 plus 5 over 2 and 2 plus 6 over 2. To obtain a result as 3 and 4, which is the midpoint of AB. This will lead us to what? to the rule. This will lead us to the rule. So generally, if A is x1 and y1, B x2 and y2, and M, which is x and y, is the midpoint of AB, then the coordinates of the point M will be x1 plus x2 over 2 and y1 plus y2 over 2. And this is going to be our rule to find the midpoint of a line segment. So it is x1 plus x2 over 2, the sum of the coordinates of the x at the point A and B divided by 2, and the sum of the coordinates of the y in the B and in the A over 2. Let us have some examples to explain such a rule. If A, 7 and negative 3, B, negative 3 and 1, find the coordinates of the point C, where C is the midpoint of AB. To find the coordinates of the point C, which is the midpoint of AB, you know that there is a rule which you have studied, which says that C equals x1 plus x2 over 2, y1 plus y2 over 2. By substituting, it is 7 plus negative 3 over 2 and negative 3 plus 1 over 2. This will lead us to 2 and negative 1. Then the coordinates of the point C, which is the midpoint of AB, will be 2 and negative 1. Let us have another example. If C, 6 and negative 4, is the midpoint of AB. C is the midpoint of AB, where A is negative 2 and 3. Find the coordinates of the point B. Here you have an example which is conversed. It is given in the opposite way. I give you the midpoint and I want you to find one of the 2 points. How can you find coordinates of the point B? First of all, we are going to say that let B equals x and y. Then what about the midpoint? It is 6 and negative 4, which is equal to the first point over 2, the sum of the x's over 2 and the sum of the y's over 2. So it is negative 2 plus x over 2 and 3 plus y over 2. Now 2 order pairs are equal, so the first coordinate equals the first coordinate. This means that 6 equals negative 2 plus x over 2, and by making cross multiplication you are going to find that negative 2 plus x equals 6 times 2, which gives 12. And then what about the value of x? X will be 12 plus 2 equals 14. Then can you find the value of the y coordinate of the point B? Of course, yes. The y equals the y. So it is negative 4 equals 3 plus y over 2. By making cross multiplication, you are going to notice that 3 plus y equals negative 8. Then to find the value of y, it is negative 8 minus 3, which gives a result as negative 11. Then you have found that the value of x is 14, the value of y is negative 11. So now you can find the coordinates of the point B, which will be 14 and negative 11. If A, 1 and 3, C, 5 and 1, AB equals BC equals CD, and A, B, C, and D are collinear points. Find the coordinates of the points B and D. First of all, you are going to notice that A, B, C, and D are collinear. This means that A, B, C, and D are on the same straight line. So try to draw A, B, C, D are on the same straight line. And you are going to notice that AB equals BC equals CD. Now we are going to let the point B equals X1 and Y1. And B will be the midpoint of AC. So, to find the coordinates of the point B, B equals 1 plus 5 over 2 and 3 plus 1 over 2. It is the midpoint of AC. So, it is 3 and 2. Now, we knew that the coordinates of the point B will be 3 and 2. The next step, you are going to notice that C will be the midpoint of BD. So, C is the midpoint of BD, and this will lead us to D will be X2 and Y2. Then, what about the midpoint? It is 5 and 1, which is equal to 3 plus X2 over 2 and 2 plus Y2 over 2. Then 2 ordered pairs equal. So the first projection equals the first projection. This will lead us to 5 equals 3 plus X2 over 2. By making cross multiplication, so 3 plus X2 equals 10. And then X2 will be 7. What about Y2? Yes, you are going to substitute. 1 equals 2 plus Y2 over 2. By making cross multiplication, so 2 plus Y2 equals 2. Then Y2 will be 0. And in this case, we can say that the coordinates of the point D will be 7 and 0. Let us have another example. ABC is a triangle. AD is a median of triangle ABC. M is the midpoint of AD, where A is 0 and 8, B 3 and 2, C -3 and 6. Then find the coordinates of the point D, and then find the coordinates of the point M. First of all, you are going to draw triangle ABC and put D as a midpoint. So when you join AD, then AD will be a median of triangle ABC. Plot the point M as it is the midpoint of AD. Then, to find the coordinates of the point D, it is the midpoint of BC. So, what about D? It is 3 plus -3 over 2 and 2 plus 6 over 2. To obtain coordinates of the point D as 0 and 4. Then, M will be the midpoint of AD. So, try to find the coordinates of the point M. Then let M equals X and Y. So, M equals, that's correct, 0 plus 0 over 2 and 8 plus 4 over 2. To obtain a result as 0 and 6. Another example. If A, 3 and 2, B, 4 and -3, C, -1, -2, D, -2 and 3 are vertices of a rhombus. Find the coordinates of the point of intersection of its two diagonals, then find also the area of the rhombus. First of all, you have a rhombus. Try at the very beginning to draw the rhombus ABCD. Join AC and BD, the two diagonals. These two diagonals will meet at a point which is M. So let M be the point of intersection of the two diagonals. Then M will be the midpoint of AC. Then, can you find the coordinates of the point M? Of course, yes. M equals what? Equals 3 plus negative 1 over 2 and 2 plus negative 2 over 2. So M will be 1 and 0. Then the coordinates of the point M will be 1 and 0. Now, we have found the point of intersection of the diagonals. The next question is how to find the area of the rhombus. All of you knew that area of rhombus equals half times diagonal 1 times diagonal 2. So you want to find the length of AC and the length of BD. First of all, try to find the length of AC. It is square root x1 minus x2 all to the power of 2 plus y1 minus y2 all to the power of 2. Then it is square root 3 minus negative 1 all to the power of 2 plus 2 minus negative 2 all to the power of 2, which will lead us to square root 4 to the power of 2 plus 4 to the power of 2 to obtain a result as 4 square root 2 units. This is the length of AC. What about the length of BD? By the same way, BD equals square root 4 minus negative 2 all to the power of 2 plus negative 3 minus 3 all to the power of 2 to obtain a result as square root 6 to the power of 2 plus negative 6 to the power of 2, which gives 6 square root 2 units. Now you have got the length of AC and BD, which are the two diagonals. So what about area of rhombus ABCD? Area of rhombus equals half the product of its diagonals. So it is half the product, it means multiplication of AC and BD. So it is half multiplied by 4 square root 2 multiplied by 6 square root 2 to obtain a result as 24 squared units. Another example, if A, negative 1, negative 1, B, 2 and 3, C, 6 and 0, D, 3 and negative 4 are 4 points in perpendicular coordinate plane. Prove that AC and BD bisect each other, then identify the type of the figure. What's the meaning of AC and BD bisect each other? It means that the midpoint of AC is exactly the same as the midpoint of BD, then these two line segments will bisect each other. At the very beginning, we are going to let M be midpoint of AC and try to find the coordinates of the point M from the points A and C. So M equals negative 1 plus 6 over 2 and negative 1 plus 0 over 2 to obtain a result as 5 over 2 and negative 1 over 2. This is M from the 2 points A and C. Then let N be the midpoint of BD. Try to find the coordinates of the point N. So it is 2 plus 3 over 2 and 3 plus negative 4 over 2 to obtain a result as 5 over 2 and negative 1 over 2. Then you are going to notice that the midpoint of AC is the same as the midpoint of BD. And in this case, we can say that AC and BD bisect each other. To identify the type of the figure, we are going first to find the length of AB. How? as we have taken in the previous lesson. It is square root negative 1 minus 2 all to the power of 2 plus negative 1 minus 3 all to the power of 2, which gives a result as 5 units. What about BC? It is square root 2 minus 6 all to the power of 2 plus 3 minus 0 all to the power of 2, which gives a result as 5 units. Then what about the length of CD? It is square root 6 minus 3 all to the power of 2 plus 0 minus negative 4 all to the power of 2, to obtain a result as square root 3 to the power of 2 plus negative 4 to the power of 2 all equals 5 units. What about the length of AD? It is square root negative 1 minus 3 all to the power of 2 plus negative 1 minus negative 4 all to the power of 2, which give a result as square root negative 4 to the power of 2 plus negative 3 to the power of 2, which give a result as 5 units. Here you are going to notice that AB equals BC equals CD equals AD equals 5 units, and this is going to be number 1. What about the length of AC, the diagonal AC? It is square root negative 1 minus 6 all to the power of 2 plus negative 1 minus 0 all to the power of 2, to obtain a result as square root negative 7 to the power of 2 plus negative 1 to the power of 2, to obtain a result as square root 50, and this will lead us to 5 square root 2 units. Then what about the length of BD, the other diagonal? BD will be square root 2 minus 3 all to the power of 2 plus 3 minus negative 4 all to the power of 2, which give square root negative 1 to the power of 2 plus 7 to the power of 2, to give a result as square root 50, and this will lead us to 5 square root 2 units as the length of the other diagonal. Here you are going to notice that AC equals BD. It means that the two diagonals are equal in length, and this will be denoted by number 2. From 1 and 2, you are going to notice that the figure ABCD will be a square. Prove that the points A, negative 3 and 0, B, 3 and 4, C, 1 and negative 6 are vertices of isosceles triangle at vertex A. Then find the length of the line segment drawn from the point A perpendicular to the line segment BC. First of all, try to draw triangle ABC, isosceles triangle at vertex A. This means that AB equals AC. Then try to draw a perpendicular from A on BC to meet BC at the point D. And this will be, AD will be perpendicular on BC as you have taken in the previous years. First of all, can you find the length of AB? Of course, yes, it is square root negative 3 minus 3 to the power of 2 plus 0 minus 4 to the power of 2, which give square root negative 6 to the power of 2 plus negative 4 to the power of 2, and this will lead us to square root 52 units. It means that the length of AB is 52, root 52 units. Then what about the length of AC? It is square root negative 3 minus 1 all to the power of 2 plus 0 minus negative 6 all to the power of 2, which gives square root negative 4 to the power of 2 plus 6 to the power of 2, to give a result as square root 52 units. Here you are going to notice that AB equals AC equals square root 52 units. Two sides in the triangle are equal, so we can say that triangle ABC is isosceles triangle. In the isosceles triangle, since AD is perpendicular on BC, it means that BD equals DC. Then you are going to notice that the point D will be midpoint of BC. So can you find the coordinates of the point D? Of course, yes, as it is the midpoint of BC. So D equals 3 plus 1 over 2 and 4 plus negative 6 over 2 to obtain a result as 2 and negative 1. Now you have the coordinates of the point A and the coordinates of the point D. Can you find the length of AD, the distance between A and D? Of course, yes. So AD equals square root negative 3 minus 2 to the power of 2 plus 0 minus negative 1 to the power of 2. Then it is equal to square root negative 5 to the power of 2 plus 1 to the power of 2 to give a result as square root 25 plus 1. So AD will be square root 26 units. And this is going to be the length of the line segment drawn perpendicular from A on BC. By the end of this example, we reached the end of our program today. I wish all of you the best of luck and bye-bye.